tell me?
Yes.
I don't think you will, but... Okay. Now, we have a lot to do today. We also, if I finish today, I don't see you tomorrow, do I? But I see you again on Wednesday and Thursday. So maybe Wednesday would be a good time for you to be sure you ask questions. If we have time on it today, we'll do that. But if you have homework questions, you need to be getting those answered because we're going to turn it in on Thursday. Okay?
Is the test Friday?
I think so. Right now we're planning on that. I may have to adjust after I see how the rest of the week goes. But I think for you guys, we ought to be able to do that. Okay, so P6, very, very simple. P6 is all about adding or doing operations with complex numbers. Now, we already did a problem where we, let's just do one for practice, where we ran into an imaginary number. Let's say you are going to solve this equation. And let's say you are told you have to complete the square. Now, remember, no matter how we do it, we'll get the same answer. But let's say you're told you're going to complete the square. All right, we talked about that already, right? We should remember that. How do we complete the square? First thing we have to do is move the 10 over because we are making room for this extra number we're going to add in, right? Now we got to figure out what that extra number is. So remember how we do that? Half of 6 is 3, squared is 9. So I'm going to add 9 to both sides. Now the whole purpose of the exercise is to make this a square. So what is this? X plus 3 squared equals -1. Right? Okay. Now, what's the next step? Square root both sides. And when we square root a squared, we just get, they cancel out, so we have x plus 3 equal to plus or minus I, because the square root of -1 is I. And then we add the 3, or subtract the 3, and there we go. So we know complex numbers, imaginary numbers, come up. They come up. Now, backing up a minute, remember when we were solving on our calculator? You graphed the equation, and what were you looking for? If you had to solve with your calculator, what points did you look for on the curve? The x-intercepts. This problem, if you graphed it, would look like this. It doesn't cross the x-axis because it has no real zeros, no graphable zeros. Now, does it have zeros? Yes, if you plug these into the equation, you would get 0, but you can't graph them, okay? So when that happens to you, you say there are no real zeros. And then you need another strategy like completing the square, the quadratic formula, to actually find them. Your calculator won't do that for you, okay? All right, so in section P6, all you're asked to do is take, and your book uses the notation Z sub 1, so I'm going to do that. So here are two numbers. The name of the first one is Z sub 1, and the name of the second one is Z sub 2. Do not be confused by that. That's just their names. Some books use W. Your book uses Z, so we'll just go on. Two complex numbers, sort of like the ones we got down here. Could you add those two numbers together? I think you could, and it would probably take you about 1 second. What is the sum of those two numbers? Don't make it hard or tricky, do the obvious. The sum of those two numbers, 6 minus 2i. When you add complex numbers, you collect like terms. You add the parts without the i's, and you add the parts starts with the i's. Easy. Subtraction works the same way. If we're not careful though, sometimes when we subtract, we screw up because we don't distribute this negative all the way through. So this would be 2 plus 3i minus 4 plus 5i. Now it seems so easy. Just remember to do it when you're doing it. So we end up with negative 2 plus 8i as our answer. Does that seem okay to everybody? Now what about multiplication? Here's the addition, here's the subtraction. What do we do for multiplication? So that would be 2 plus 3i times 4 minus 5i. Okay, what would that be? How do you think we'll do that? The actual words distributing, I think of it as foiling. Same thing, right? We're going to take these times those. So we'll take first times first, outsides, insides, and last. Okay, how does that look to everybody? Does that make sense? Now we need to talk about something.
The I squared.
We need to talk about the I squared. What do you remember about I squared? That it's negative 1. And the reason it's negative 1 is because I is the square root of negative 1. So when I square that, the radical and the squared cancel, right? We've been doing that a lot. And I end up with I squared equal to just negative 1. So when I get an I squared, I'm going to think of it as negative 1. Which makes this a positive 15, which can be added to my positive 8, giving me a grand total of 23.
Plus 2.
And then these two are like terms, and there we go. Everybody good with that? Okay, so addition, subtraction, multiplication, the only thing left is division. So that would be 2 plus 3i over 4 minus 5i. Anybody remember or have a thought on how we might handle this? Griffin? Can you remember? Close. I don't multiply by 4 minus 5i. I multiply by 4 plus 5i. Does anybody remember what we call 4 plus 5i in this case?
Start with a C.
It starts with a C.
Conjugate.
It's called the conjugate. And does anybody remember why? I mean, why are we doing this? What's going to happen, Brenton?
You're canceling the i's in the bottom.
Exactly. And Brenton, what's wrong with having an I in the bottom?
It's not a real number.
Well, it's not a real number. More importantly, it's a radical, right? And what is our rule about radicals?
You can't divide.
Can't have them, can't divide by them. So any radical, whether it's real or imaginary, I don't want down there. So here we go. Big foil, lots of foil on top. First, outsides, insides, last. On the bottom, first, and then here's what Brenton was talking about. There's my outsides, there's my insides, and last. Notice in the bottom, just as Brenton predicted, your outsides and insides are going to cancel. Now, we still have an I in the bottom, or do we? No, it's I squared, which is negative 1, so that's really a positive 25. So my denominator is really 41. 16 plus 25. Keep an eye on my arithmetic, is that okay? And then what's your numerator? Well, that's negative 15. So I have negative 7 plus 22, I think if we talked about this the other day, but just in case we didn't, even, I mean, obviously nothing cancels here. You wouldn't even try to cancel anything here. But if you ended up with something like this, you're still not going to cancel. Because in an expression like this that has 3 components, if you're going to cancel, you have to be able to cancel out of all 3. So this does not reduce. Do not touch that. This, we could reduce. Because you can cancel a 3 out of all 3 parts. If you can't do the triangle of cancellation, then don't cancel at all. So this is a no. This one would be -2 plus or minus 3i. You can cancel that one. 2 other little tidbits to throw in, both of which you're probably familiar with, but I just want to double check. One is, if you are asked to multiply 2 radicals together, do not say this is the square root of 6. I understand what you're doing, it makes sense, it's logical, but it doesn't work. With negative radicands, this number is called the radicand here under the radical sum, step 1 has to be take out the I. Okay? So you're going to rewrite, before you do any multiplication, you're going to rewrite this as I root 2. And this one is I root 3. Now you can multiply and get your root 6. But you're also going to get an I squared. So the answer actually is negative root 6. You've got to take care of the negative radicands, take care of the i's, pull the i's out before you do any arithmetic. Okay? And then the other thing is, and this is quite honestly, I know of no practical application of this. I know of no one who does this in the real world, but it's in every math book, so we're going to go ahead and do it. I to the 27th. Simplify I to the 27th power. Okay, let's think about that for a second. That would mean all these i's times each other, right? I'm not going to write it all down, but these guys are all times each other, right? 27 of them. And we've already talked about that pair right there makes a -1, and this pair makes a -1. So putting those 2 pairs together, and remembering it's pure multiplication. Everything here is multiplication. You have -1 times -1. So these 4 i's make a 1. And these 4 i's would make a 1. And they're times, so 1 times 1, basically I can ignore them, because 1 times 1 is just 1. And every 4 i's is going to be a -1. Or excuse me, every 4 i's is going to be a 1. Now, what am I interested in? Not all those 1's. I'm interested to know if, after I've done all those groupings, are there any left? Right? So think about it. You have 27. I did not draw 27. You have 27. If you group them by 4's, are there any left? There'd be 3 left. Because 27 divided by 4 leaves a remainder of 3. So I have 6 of these groups, which I ignore, because it just means 1 times 1 times 1 times 1. I ignore that. I'm interested in the leftover I on the end. What's that? Well, 2 of them make a -1. So what do I have left? Well, I just have negative I. Where's my problem? Negative I is what's left. Because I have all of these ones, and then I have 3 extras. 2 of them would make a negative, and then the extra is just an I. What about this? What would I to the 81st be? Now think about it. We're only interested in what's left after you do the groupings. So take out all the groups of 4. How many would be left if you took out all the groups of 4? 1. Right? So you'd have all these groups of 4, and then you'd have, here's all your groups of 4, and then you'd have this lonely little I on the end. So this reduces to just lonely little I. What if we had 2 left over? That'd be -1, because 2 left over would be I squared, and that would be -1. What if we didn't have any left over? What if it all got grouped? Then it would just be 1. 1 times 1 times 1 times 1 times 1.
So are you just looking for the remainder?
Yep, because all the groupings make just ones, and it's a multiplication problem. So multiplying by 1 doesn't accomplish anything, right? So we're only interested in what is not being grouped into a 1. Okay? All right. Now the good news about P7 is you already know part of it. The first part of P7 we've already talked about. There are problems that look like this. Have I already given you guys the vocab sheet?
Yeah.
So, now, there's more than one way to do this, absolutely, positively, but I'm gonna do it like a calculus student with the number line. What number do I put right in the middle of the number line? -5. Remember, you gotta think of this as a subtraction. We're doing distance is a difference. Or, another way of thinking about it is, it's just the opposite of what's in there. So if there's a +5 in there, you're gonna plot a -5. If it said x minus 5, we would plot a +5. And then, what do we use this number for? To go up and down that many. So we're gonna count out 4 and back 4, and those will be closed in dots because of the or equal to, right? And then we're gonna shade. And we're either gonna shade between the dots or outside the dots. And this tells us how to shade. That says greater than, more than. So we're gonna shade out here and back here. So our answer is everything from -infinity to -9, or -1 to +infinity. Michael? Is it an emergency? All right, hurry up. Everybody remember doing these? Okay. Now we're gonna look at a couple of new kinds of problems. Just a couple. The new problems look like this. No absolute value. This is called a quadratic inequality. It's going to involve a number line and shading, just like this one did. But since it's a different kind of problem, we're gonna do it a little bit differently. Anybody have an idea how to get started? Or just take a wild guess? Do you have to factor it? Absolutely, that sounds like a magnificent plan. We're going to factor it. Now, the question that should be popping into your head is, Mrs. Ford, not everything factors. What do I do if it doesn't factor? Well, I'm going to answer that two different ways. First of all the ones I give you to be graded, test or quiz, all of them will factor. Okay? Your homework, there may be some in the book that don't factor. What do we do with any quadratic that doesn't factor? We either use the quadratic formula or we complete the square. Okay? But these are easier with factors, so I'm going to make sure whatever I give you for a grade will factor. All right? Now, I got it factored. I'm going to put 2 dots on my number line. Anybody want to take a wild guess where those dots are going to be? -1 and 9. Notice that my dots must go on the number line in the order that they naturally occur. So I have to put -1 here and 9 here. Those are open dots. Does that make sense to you?
Yes.
Yep, that's what we're equal to. That rule never changes. Now, those 2 dots have split this number line into 3 pieces. The 3 pieces are this piece, and this piece, correct? Now I need to figure out which of the pieces of the number line
So this way you plug.
are going to make the problem positive. Greater than 0 means positive. There are some numbers I can put in that will give me a positive answer, and there are other numbers I can put in that would give me a negative answer. I want the positive ones. They will either come from here, here, or here. So I'm going to pick a number over here, like -2, and I'm going to put it in and see what happens. If I put in -2, this parentheses would be a negative number. If I put in -2, this parentheses would be a negative number. Now they are being times by each other. Negative times negative would make what I want, so that is part of my solution. Now notice, I didn't even actually work out the numbers because it's not the numbers that are important. What's important? Positive or negative. If you want to work out the numbers, fine, but you don't need to. Now, pick a number in here, any number in this region. 1. If I put 1 into my parentheses, what do I get? Negative, this would be negative, but this one would be positive. When I multiply those, because this is a multiplication, when I multiply them, do I get a positive result? No, so this is not part of my answer. I don't want it, it's not part of my answer. Pick a number over here, 11. If I put 11 in, I get positive and positive.
Yes.
What happens when I multiply those? It's positive, and that's what I want. So my answer is everything from, from negative infinity to -1, or from 9 to infinity. Boy.
Do you not need to do the special bracket around, instead of parentheses, the bracket
Where would the bracket go?
around the -1 and the 9?
Okay. When do we use the bracket, folks? If the dots are filled in.
Okay.
When they're open, we use a parenthesis. This one's gonna have some filled in dots, Michael, because it's got
Yeah,
an
no, I see
equal
it.
to it. All right, oh boy, this is a step up. I'm getting wild and wacky. What do you want to do with this? Okay, now this gives me an opportunity to talk about the 10 commandments of mathematics, okay? One of the commandments is, oh, speaking of that, let me hold off on that, because I gotta tell you about another commandment. They're kind of tied into this commandment. Math league t-shirts. Finally got them ready to go, just sent them off for the design to be, formally put together. I can't help it, I gotta tell you what they say, they're so cute. Everybody's going to want one. We have long sleeved options and short sleeved options this year. So cool. On the front it says, Cathedral Math League, it's all fun and games. And then on the back it says, until someone divides by 0. Come on, that's cute. And you all want one, I know. And we'll hang out the order forms and we sign up for Math League. That'll be soon, as soon as it gets it together. They're so cute. They're gonna be dark green with bold letters. Come on, you want one. You wear them on Fridays.
What color are they?
Dark green, bold letters. Huh?
That looks good for hair.
That's why I picked it. Looks good with mine too. So yeah. All right. So here we go. This is okay. So we cannot divide by 0. So when you say to me, let's divide both sides by x, I have a bit of a problem because x is a variable. And what do I not know about x? Its value. Could its value potentially be 0? Yes, and therefore I cannot divide it. Now in geometry class, you were allowed to divide by variables because generally in geometry, what do the variables represent? Lengths of sides or measures of angles or something like that. So it was perfectly okay because those variables couldn't be 0. But in a random polynomial like this, you have no idea what x is. You got a problem just even magnified because you not only don't know if it's 0, but it could be negative. And if it's negative, when I divide it, I have to switch the symbol, right? We're not dividing by variables. Not in pre-calculus, we're not doing it till we get to trigonometry. Okay, so I can't divide, all right? Made that point. Now what? What do I do instead? Subtract it. Now, when I subtract it, Eli? You're Eli, right?
Yeah.
Yes. What's this stuff?
It's gotta go.
It's gotta go. It's gotta go. So tomorrow, Eli, I'm making a note to myself. If I remember, I'm gonna track you down some period of tomorrow. I will find you. And if you're not shaven, there's gonna be bad news. All right, so you get it shaved. Consider this your last warning, okay? What do I do now? I've subtracted, I got my 0. We've got to have a 0. We gotta have a 0 because this is all about being positive or negative. So 0 is the middle. We're either greater than 0 or we're less than 0. All right, so here we go. What do you think I'm going to do next? Factor it. And how do you factor something like this? Take out an x. I'm not dividing it. Oops, I'm not dividing it out. I'm just taking it out. So it's still there. And then, what about this guy? X minus 2x plus 2. We call that the difference of squares. So now it's factored completely. So I go to my number line, and this one's going to have 3 dots on the number line. And the dots are going to be colored in. where are the 3 dots? 2, -2, and 0. Now, when you put them on there, please put them on in order, guys, or your answer's gonna be all messed up. Everybody still with me? All right, what do we do now? Now we've got 1, 2, 3, 4 sections to pick. So luckily, we can split up. So you guys in that group over there, you pick a number over here and check it. All right. You guys in the middle, you check this section. You guys over here, check this section, and then I'll do the last section. Okay. So go ahead, get busy. Pick a number, put it in, and see if you are negative this time. Less than 0. We want negative outputs. So I'm going to put in. So you're plugging in a number in your space and figuring out if it's positive or negative. So group 1, you got positive or negative? You got negative. So that's what I wanted, so that's going to be shaded in. Your section is shaded. Group in the middle, what'd you get? You got positive. Positive is not good because this problem wants negative. Less than 0. Group 3, what'd you guys get? You got positive or negative?
Negative.
You got negative, and that's why you're nodding. That worked out to be a negative number. And then I got a positive, so I X'd mine out. So group 1 and group 3 got negative answers, and this problem is all about negative. Group 2 and I got positive answers, so they don't work. They don't work. So my answer is everything from negative infinity to -2, and that is bracketed, Michael, in union with everything from 0 to 2. Now, you might have noticed, or maybe you remember from last year, that as I'm coloring in sections of the number line, it seems like we got some alternating going on. So here I have these 3 sections. This one worked, and then it didn't, and then it did. This one worked, and then it didn't, and then it did, and then it didn't. Did you notice that or remember that?
Yep.
That is not a hard and fast rule, but it will happen in every problem that isn't unusual. So what would be an example of an unusual problem? Let's suppose we factored this, but instead of getting that, we got this. Now, what's unusual about that? 2 of the factors are the same. So while there should be 3 dots, there's only going to be 2 because 2 of them are the same. That is unusual. If it's an unusual problem, you have to do what we have been doing, and that is check every single space. If it's not an unusual problem, if all of the factors are different, nothing weird going on, then they will always alternate. So the minute group 1 told me it worked, then I could have just skipped all you guys and said, okay, that one works, this one won't, this one will, that one won't. They always alternate unless there's something odd about the problem. Yes?
What would be something odd about the problem?
2 factors that are the same.
Okay.
That's the biggest oddity. 2 factors that are the
Is
same.
there anything else?
With polynomials, that's about all that pops up is repeated factors. So it wouldn't have to be 2 of them, it could be 3 or 4 or 5 of them, but anytime a factor repeats, that would throw things off. Obviously, if we got really crazy, you know, and stuck a radical in it or something, I mean, that's odd, that's gonna throw things off. But if it's just straight factors, it'll always be fine unless you have repeated ones. All right, we have 2 more things to do. And then we can actually start reviewing because we're gonna have time. Michael, do we need to stand up and stretch a moment? You look like you're phased out there a little bit.
I think I'm alright.
Are you sure?
Yeah.
All right, why don't we just all stand up a minute, say hello to our neighbor, shake hands. I can't. Talk about how excited we are about the math week shirts.
Wait, that's actually like.
Okay, let's share. One person, what fun thing did you do over the weekend? Stay fair. I hope you went Sunday. Oh, wasn't the weather terrible?
Yeah.
Oh, okay. Probably not many people there.
No, it was great.
Awesome. What's your favorite food there?
Oh, I didn't eat anything.
Oh, okay.
Oh, that's okay.
Oh, I just
I had some taffy though.
All right. Okay, let's come back together now. Here we go. Got a lot going on. If it's an emergency, you can go to the bathroom. I tell you what, I'm 57 years old, have 4 kids, had cancer, and I can hold it. I don't get it why people can't. But anyway, it is what it is. This is a rational inequality. We are going to use a number line just like we have. That's our common theme. We use a number line, number line, number line. But the problem looks different than the other ones we've done. It certainly is not an absolute value, and it's not written out, you know, it's not a polynomial. It has a denominator, it has a fraction in it. So it's going to be handled a little bit differently, but eventually we're going to get it to the number line stage and we're going to do it exactly like that. All right? So here we go. First thing we do not multiply both sides by x minus 4. I understand why you would do that, and I understand how come you want to do that, but you need to understand that you can't. Because again, I don't know whether x minus 4 is positive or negative. Could it be positive? Yeah. Could it be negative? Yeah. I can't multiply in an inequality by something that could be either. Because if it's positive, that stays the same. If it's negative, it changes, and I don't know what to do because I don't know if it's positive or negative. So that is not an option. Don't do it. Somebody will, and I'll just mark it wrong and make a comment. You can't do it. Instead, I want you to subtract 2 and get that crazy 0. We want to have a 0. Less than 0 means negative. So I am looking for things that will make this negative. Before I can actually find those things, I need to subtract these 2 fractions. So I move the 2 over. Now I've got a subtraction problem, right? So what do I do when I have to subtract fractions? Oh, no, not reciprocal. Common denominator. Yeah, I need the denominators to be the same. When I subtract fractions, I have to have the same denominator. So now I've got a common denominator, it's x minus 4. And what have I got up on top? I have x plus 3. Okay, then what? Minus 2x plus 8. Okay, so I multiplied top and bottom by x minus 4. And then I'm going to put all this together in one numerator, because now the denominators match. So I'm going to put it all together. So I have x plus 3 minus 2x plus 8. Everybody okay with that?
Yeah.
Now let's simplify. So we have negative x plus 11 over x minus 4. Now I'm going to put 2 dots on my number line. I'm going to take a wild guess where the dots are. One of them is definitely at positive 4. The other one is actually at positive 11. That's a negative x. Okay, here's why. We said positive 4 because that's what makes this 0. What makes negative x plus 11 equal to 0? What makes that equal to 0? Isn't it positive 11? If you're going to get confused by these negatives, and all these problems almost always have a negative there, almost always, then you're going to have to write it out. Just work it out. Set it equal to 0 and solve, and that's where your dot goes. You could set this one equal to 0 and solve too. That's how you got the 4. You just do that in your head. Here are my dots. Now here comes another little picky technicality. I see the or equal to. I want to color these dots in. And I do color in the 11. But I won't color in the 4. Think of my math league t-shirt. Why am I not going to color in the 4? What happens if I put 4 into my equation? I get a 0 in the bottom, and that's never ever allowed. So that dot will automatically be open. Denominator dots are always open regardless of the sign in the problem, the symbol in the problem. The 11 is colored in because of this guy right here. If there hadn't been an or equal to there, that would also be an open dot. But it's closed because of the or equal to. Now, what do you think we're going to do next, now that we've got the dots on the number line? We're going to figure out where to shade. And just like before, they're going to alternate. There's no squared factors or anything weird about that. It's a normal problem, so they're going to alternate. So I'm going to pick one number. I like 0. 0 happens to be over here. If I put 0 in, does that fraction end up negative like it's supposed to if I put 0 in? Yes. So this works. This then will not. And if you don't trust me, try it. You can always try it. Go ahead, stick a number in. It won't work. If this one worked, this one didn't, this one will. And the answer to the question is everything from negative infinity to 4 in union with everything from 11 to infinity.
Will it state that you need to write it in notation? Or should we just?
Well, I will not mark it wrong if you don't, unless the directions say you have to, okay? You're always welcome to use interval notation. If the directions say you have to, then yes, you have to.
Where did you plug in 0 to get the first shading?
Yeah, I plugged 0 in right here into my problem. So when I put 0 in, I got 11 over negative 4, which is a negative number. So that meant where 0 is on the number line is a good section. All right, I want you to try one more with your partner. Use this as a model. These are all done exactly the same way, just different numbers. So let's try this one. All right, let's give this one a try. Work with your partner. I think I need to take attendance.
Yeah, minus 0.
X plus 30.
You're all here today. Good for you. I'm gonna go ahead and I'll be working up here, but I'm not gonna say anything. Don't look up here if you can help it. You're trying to do this with your partner.
Yeah, I'm not sure. It's possible.
And then you all you multiply by x plus 3, top and bottom, then yeah. And then you make a number line.
Oh, we did that wrong. It was minus.
And then the number line would be, yeah, which one? Minus, and you go
It's negative x.
No, there's no equal to. Negative 4.
That's gonna be positive 6 over 1.
So is it a positive equal?
Which equals
No, because if you do negative
You
1
want a
x minus
positive,
8,
that's right. You wanna get a positive result.
so it's
Wait, so negative of a negative 8 is x squared, right? I thought the negative 8 flipped and then it x.
Wait, so
So it'd be negative.
I got back
the middle one is negative.
Once I get the graphing type thing,
So once you plug like the number
Well, you have to pick a number.
Okay, how do
so
you
how what two numbers are you comparing with? So I got a positive.
Pick a
I
number.
said plugged it in.
Any other number. No, anything you want. So what number you want to pick? Now five.
And then you turn it into
So I'm gonna put 5 into my problem. Okay? When I put 5 in, I'm gonna have a negative top
and they're all parentheses.
and a positive bottom. That is not positive, right?
And then
I need a positive result. That means this section doesn't work.
negative positive between negatives on the left and positives on the right.
Well, it depends on what the problem is. This section was negative positive. But that ends up negative.
Where are they getting the negative?
Okay, I think it can be.
Wait, mine works.
I got, first of all, are your dots at -8 and -3?
They were.
Okay. All these negatives baffle me, and I'm old and the teacher, so I do this work over to the side. How did I tell you where to find the dot if you were unsure? Set it equal to 0 and solve it. So I set my numerator equal to 0 and I solved. There shouldn't be any question about that. That gives you -8. The denominator, I can just tell, is -3. So there are my 2 dots on the number line. Now, there's nothing unusual about this problem. No squares or anything radicals, nothing funky going on. So I know my answer sections are going to alternate. So I picked a number. The easiest number for me is 0. So I picked 0, which is out here. Doesn't matter where it is. Pick a number anywhere, doesn't matter. I picked 0. When I put 0 into my fraction, I got -8/3. That's a negative number. It is not a positive number. I want a positive number. So this section doesn't work. It gives me a positive answer. Or I mean a negative answer. It gives me a negative answer. So if this one didn't work, then I automatically knew this one would. If I didn't know that or didn't trust that, I would pick a number in here and check it. If this one works, then this one won't. But again, you can pick another number and check it. Always you can do that if you want. And the answer came out to be just the section of numbers between -8 and -3. Okay? All right. One more thing and then we'll do some review. The last thing, I need you to open your books, please. These are word problems. We're going to take them out of your book. We're going to P7. Yeah. Oh, I didn't tell you the page. Page 64. Go to page 64. Sorry about that. I guess I thought you were looking that up. In order to do, we are getting ready to do problem number 33 on page 64. 33 on 64. Projectile motion. In order to do projectile motion, you need a formula. You do not need to memorize this formula at this point. Although, after you've practiced a few, you probably will, because it's not that hard. The formula for projectile motion is this. I'm going to go ahead and use H's. I like H's better than S's. Your book uses S's, but I'm going to use H's.
Are those zeros?
Yeah, these are little zeros. Yep. Little subscripts. And we'll talk about what that means. You may already know. So it's -16t squared.
Is that U or V?
It's a V.
Okay.
V sub naught, or V sub 0t plus H sub 0. Now, T is the time usually in seconds. Now, that may be adjusted, but normally it's in seconds. It could be in minutes or hours or something, but almost always it's in seconds. So every place I see a T in the formula, I'm going to be plugging in the time. This is the height at time T. So, if we wanted to know how high an object was above the ground after 3 seconds, I stand on the ground and throw it up, how high is it after 3 seconds? I would simply plug 3 in for the t's. And then whatever it equaled would be the height. V sub naught, this is read V sub naught or V sub 0, is the initial velocity of the object. So if you think about it, if you're going to throw a ball up in the air, you're releasing it with a certain velocity. Now, if I stand on the balcony holding a ball and drop it, the initial velocity is 0. Because when I release it, I'm not giving it any force at all, I'm just dropping it. So sometimes the initial velocity is 0. And you would just put a 0 in there, which would wipe out that term. H sub naught, you want to guess what that is? The initial height. If you are throwing an object from ground level, the initial height is 0. If I'm dropping it from the balcony, then my initial height is however high the balcony is, right? Okay, so when I look at number 33 on page 64, a projectile is launched straight up from ground level with an initial velocity of 256 feet per second. So I need to write an equation using this formula that models that. So I'll have negative 16t squared, that never changes, plus what? 256t plus what? 0, ground level. So this is the equation for the projectile motion of this particular problem. Everybody okay with that? We're going to use that formula for all of our projectile motion problems, but we'll be plugging in different numbers depending on the situation. All right, now we're going to answer the question. When will the projectile's height above ground be 768 feet? When will the height be 768? So you're going to plug 768 into this equation. I hope you know that. The question is, where are you going to plug it? You're either going to plug it here or you're going to plug it here. Where are you putting the 768? In for H. It's going in right here. 768 is negative 16t squared plus 256t. H of t is the same as y. Remember? It's just a variable. It has 2 letters in it, but it's one variable. Cassie, that guy is the height. And I know the height is 768. All right, what do I do with that? I set it equal to 0. That's a quadratic equation. So negative 16t squared plus 256t minus 768 equals 0. Now, I am not excited about those numbers at all. I happen to know this is divisible by 16. Would somebody check? Is this number divisible by 16? How many times?
48.
And I'm dividing by negative 16. It makes my life and your life, our lives, so much easier to get rid of those giant numbers. Right? Now, what do you want to do with that quadratic? You can actually factor it. If you don't see the factoring or don't want to mess around with it, then you could also complete the square or use the quadratic formula.
So it'd be 24.
Okay, now something a little odd is happening here. I'm getting 2 answers. Okay, now wait a second. Let's talk about this. Let's visualize it. We have shot an object up into the air. Okay, so I've shot this object up into the air. What's going to happen to it at some point? It's got to come down, right? I mean, obviously we understand gravity and all that stuff. And I want to know, when is it going to be 768 tall? Why are there 2 answers?
Because it's going to go down.
Once on the way up and once on the way down. So the question is, when will it be 607, whatever that number was, when will it be that high? It'll be that high after 12 seconds and after 4 seconds. Once on the way up, once on the way down. Guys, this equation right here is a t squared or an x squared. They are always parabolas. I think I mentioned that the other day. They're always parabolas. When you put a negative in front of it, it's a parabola opening down. certainly that makes sense to you in context of throwing an object up into the air. It goes up and then it comes down. Next question. When will the projectile's height be at least 768? At least 768 would mean it had to be here. So what would your answer be? Between 4 and 12. And would I bracket that? Because it says at least. If it said more than, just more than, then I wouldn't bracket it. Does that make sense to you? Vocabulary-wise? All right, and then the last question says, when will a projectile's height above ground be less than or equal to 768? It would be this part right here, right? Which would be 0 to 4. Okay, so we got 0 to 4. Or, okay, this was 12. I don't know when it ends, or do I? No, it doesn't end at infinity, kids. That ball's going to hit the ground and stop. It doesn't keep going. Would it be 16? Why would it be 16? Parabolas are symmetric figures. If it took 4 seconds to get up to this point, it's going to take 4 seconds to get down. Now, your physics teacher will have a little bit different spin on this. This is a purely mathematical model. It is not taking into account things like the wind that can change things, right? It's not taking that into account. So this is not like purely accurate, but from a mathematical standpoint it is.
In the very beginning, when we did our equation, we didn't use initial height. We just took it out of the equation.
No, we didn't just take it out of the equation. Read the problem, Rachel. It says it's thrown from ground level.
Oh, okay. So it's 0. Okay.
Yeah. No, we're not in the habit of just taking things out. But sometimes they equal 0.
Okay.
And you don't need to worry about that. All right, we're going to do one more problem. And then I'll be done, and you can we can start reviewing homework or something if you want. Let's look at number 34. All right, I erased my formula, so I'll put it back up here. All right, here we go. We're doing problem number 34. 34. Tell me, read the problem, and tell me what my equation is going to be. Now, this is kind of the general formula. I need an equation for problem 34. What will that equation be? H of t is what? Negative 16t squared. That never changes. When I'm in feet. It changes when I'm in meters. Anybody know what that coefficient becomes in meters? 4.9? Yep, that's what it is. Now, what's the rest of my equation going to be? Plus, what is it? 272 t plus 0. I wouldn't even put that on there. I just leave that off. Again, we are throwing from ground level. Understand that if we were throwing from the top of the school building, we'd have a plus 30 or something on the end, right? However tall the building was. Question 1. When will the height above the ground be 960? When, there's your clue, your variable is going to be t. When will it be 960? So where are you putting the 960 in? Right here. just like the last one. It's gonna be a little bit harder. What do? Move it over. You gotta have your equation set equal to 0. Now, are these numbers by any chance divisible by 16?
Yeah.
They both are? Oh, I thought they weren't. Okay, good. So we got t squared minus what?
17t minus 60 or 60.
60?
Yeah.
Actually, it's gonna be plus,
Oh yeah, so it's negative.
because I divided by negative 16 again. Does that factor? So t minus 12 and t minus 5. So what does that tell me? That tells me that I'm at the height I wanted to be now at 5 and 12. So at the same picture, basically the same picture, only I'm at my points at 5 and 12. And then, it's not gonna end at 16, where's it gonna end this time? 17. So question B says, when will it be more than 960 above the ground? Now read that carefully. When will a projectile's height be more than 960? That's right here, right? But when you write your answer, how are you gonna write it? With parentheses this time, because it doesn't say at least, it says more than. So it has to be all of this, but not including the 960s. And then the last question says, when will it be less than or equal to? Less than or equal to would be 0 to 5, bracketed. Less than or equal to, or 12 to 17, bracketed. One little caution. If we threw it off the top of the building, the picture is actually going to look like this. Would you agree with that? When you solve, you're going to get an equation just like this. You're going to be able to solve it. You're actually going to get two answers, but one of them will be this guy, which is going to be a negative number. So you will throw him out, and that will be the only time it's on the ground. You're not going to get two answers on the ground, only one. Okay? Done. Done, done. So now we've got black, we only have 4 minutes. So if you have a homework question, why don't you bring it up to me? If you don't have a homework question, you are free to go. Remembering that on Schoology today, I'm going to post the review work, which will be due on Friday, and all your P1, P7 work is due on Thursday. Okay? Tomorrow or whenever I see you again, we'll start reviewing. You two, you guys are chewing gum? Yeah. There's no gum in the school. They go down on the floor. So only chew gum is put on the floor. So I know. I want you to go put it in the waste basket, and then both of you bring me a box of full size, non-generic cleanses. Okay? And I will give you the
So like no cleanup?
No, Kleenex or cups.
Oh, non-generic.
Yeah, non-generic. I don't want that Walmart. I want cups or Kleenex. Okay? Full size, none of those little boxes. A full size box. Eli, I am hunting you down. You guys,
It's fine.
don't forget her.
Eli.
What?
Hey, what's that?
Who said Mrs. Ford? Summer, look at all the tons of homework questions that we have.